Hello everyone. Today we'll learn about the fundamentals of electromagnetic induction and Faraday's law. In the lower classes, you must have studied about the properties of electric and magnetic fields separately. Electromagnetic induction is the field which discusses about the interconnection between the electric and magnetic fields. In the year 1831, Michael Faraday and Joseph Henry independently discovered that magnetism could produce current in a wire. That means a current carrying wire can produce magnetic field in its vicinity. So electromagnetic induction can be defined as a process in which a conductor is put in a particular position and magnetic field keeps varying, or magnetic field is stationary and the conductor is moving. This process produces a voltage, or in short we call it as EMF, electromotive force across the electrical conductor. So as you see in the picture, a coil which is connected to a galvanometer, near to which if a bar magnet is brought, the galvanometer needle shows some deflection, showing that there is a connection between magnetic field and the electric field that is produced in the coil. On the basis of electromagnetic induction, the scientist Faraday proposed Faraday's law, which states that the induced voltage or EMF in a coil is proportional to the product of the number of the loops of the coil and the rate of change of magnetic field within those loops. Mathematically, Faraday's law of induction can be stated as EMF that is produced in the coil is directly proportional to change in the flux by change of time. Here N indicates the number of loops that are in the coil. Now the question is, how can we change the magnetic field around the conductor to induce an EMF in the coil? There are different ways to induce EMF in a coil by changing the magnetic field. Let us discuss one by one. The change in the magnetic field can be produced by maintaining a relative motion between the conductor, that is the wire, and the magnetic field. Change in the magnetic field can also be produced by moving the coil into or out of the magnetic field, as you see in the picture. Change in the magnetic field can be produced by rotating the coil relative to the magnet. Change in the magnetic field can also be produced by changing the strength of the magnetic field. So on the whole, you can see EMF can be generated by moving a magnet past a stationary conductor or a conductor moving through a stationary magnetic field. In both the ways, an EMF can be induced in the coil. So the induced EMF or the voltage depends on some of the factors. They are the speed of the wire traversing the magnetic field. The more the speed is, the more is the EMF generated. The induced voltage in the coil also depends on the number of loops of the wire that moves in the magnetic field. The voltage that is generated or induced is proportional to the number of loops in the coil. That is, more the number of turns or loops in the coil, the more is the EMF induced in the coil. So as there is induced voltage, there is induced current that is generated in the coil, which depends on various factors. The more loops of the coil, the more voltage is induced. The more voltage induced in the coil will give rise to more current through the resistor in the circuit. The more current through the coil gives more magnetic field. The more stronger the magnetic field generated, the stronger is the repelling force acting back onto the magnet. A coil with more loops is stronger electromagnet and push back harder. We'll learn more about the concepts and laws based on electromagnetic induction in the upcoming videos. Thank you.